This lesson is about the Md11 hydraulic system. In the first segment of the lesson, we will talk about the hydraulic synoptic page and identify the symbols, the color codes, and the indications related to the hydraulic synoptic page. In segment 2, we will talk about how to pressurize and depressurize the hydraulic system in the automatic mode. During this test, all engines will be off. In the last segment of the lesson, we will talk about how to pressurize and depressurize the hydraulic system in the manual mode. Again, all engines will be off for this test. The Md11 has 3 different parallel 3,000 psi hydraulic systems that operate continuously. Each of the 3 systems receives hydraulic power from 2 pumps. These 2 pumps receive power from their related engine. The number 1 engine supplies power to the 2 pumps in system number 1. The number 2 engine supplies power to the pumps in system number 2. The number 3 engine supplies power to the pumps in system number 3. 2 AC electrical motor-driven pumps supply more hydraulic power when necessary. These auxiliary pumps and 2 reversible motor pumps pressurize the systems for ground operations. We will operate the 2 auxiliary pumps in 2 subsequent lesson segments. During our ground check of the hydraulic system, we must also pressurize systems 1 and 2. The 2 reversible motor pumps will supply hydraulic power from system 3 to system 1 and system 2. The hydraulic system controller, or HSC, controls the hydraulic system through 2 modes of operation, manual and automatic. In the manual mode, the hydraulic system control panel, or HSCP, controls, monitors, and if necessary, resets the system and components for any aircraft failure. The HSC is on the main avionics rack in the avionics compartment. Switch lights that give commands to hydraulic system components are on the HSCP. The hydraulic system usually operates with the HSC in the automatic mode. When the HSC is in the automatic mode, the system select switch light has no lights on. When the system is in the manual mode, the manual part of the switch light is on. The hydraulic pressure test switch light does a test of the auxiliary pumps and the reversible motor pumps. We will not talk about this switch light at this time. Systems 1, 2, and 3 each have pressure lights that come on when pressure is less than 2,400 psi or more than 3,500 psi. There are 3 pair of left and right pump switch lights. The 3 sets operate the same for each system. The fault light comes on when the pressure is too low or when the temperature is too high. The off light comes on if a pump is off. The reversible motor pumps, or RMPs, are an alternative power source. The 1-3 RMP and the 2-3 RMP have equal operation. The on section of these switch lights comes on when the HSC turns the RMP on. The disagree light comes on when the RMP valves are not in the position specified by the HSC or the HSCP. Each auxiliary pump switch light operates an electric auxiliary pump. These pumps pressurize the number 3 hydraulic system. You can monitor current hydraulic system indications on the system display when you push the hydraulic Q switch on the System Control Panel, or SCP. The master caution and master warning indicators on the glare shield show when there is an alert. The engine and alert display, or EAD, shows specified hydraulic system alerts. When you push the hydraulic Q switch on the SCP, the master caution or master warning light will go off, and a reminder message will replace alert level 1 and 2 messages. The synoptic page will come into view on the system display. Push the hydraulic Q switch. The synoptic page has two sections. The bottom section shows alert descriptions and consequences, and the top section shows the current system status. Level 3 alert messages are red in a red box and have a triangle in the box. Consequences are adjacent to the alert messages. If all alerts or consequences cannot show on one page, push the hydraulic Q switch on the SCP to see more pages. Level 2 messages are amber in an amber box. Level 2 messages show below all Level 3 messages. Level 1 alert messages are amber and show below all Level 3 and Level 2 messages. Level 0 alert messages are cyan and show above the reminder message area on the EAD. Look at the symbols and indications on the hydraulic synoptic page. Engine pumps show in one of three conditions: off, on, or armed. Hydraulic system pressure shows in white digits at the head of each system in increments of 20 psi. The white digits become amber and show in an amber box when the pressure is less than 2400 psi or more than 3500 psi. After engine start, the applicable engine pumps will show a green circle with green veins. When the engine is at idle, the HSC does a pump test on the pumps. After the pumps pass the test, the right pump will show an armed indication, a white circle with a white A. If a left pump has low pressure or the case drain temperature is high, the pump will show as an amber circle with amber veins. The armed right pump will then pressurize the system. If an engine pump failure occurs because the pressure decreases to less than 2400 psi, again the left pump will show an amber circle with amber veins. An amber P will show adjacent to that pump on the synoptic. If the case drain temperature for an engine pump increases to more than 118 degrees Celsius, an amber T will show above that pump on the synoptic. The auxiliary pumps use two of the same displays as the engine pumps. A white circle shows that the pump is off, and a green circle with green veins shows that the pump is on. Schematic lines show the condition of the hydraulic pressure lines. The schematic lines are green when the applicable pumps are on and the pressure is more than 2400 psi for 2 seconds. The schematic lines are white when the pumps are off. Reversible motor pumps, or RMPs, are off when the double valve symbols are closed. The closed indication shows the valve symbols perpendicular to the schematic line. With the RMPs on and the system at 2400 psi for 2 seconds, the valve symbols become green and the double lines show parallel to the schematic line. Hydraulic fluid quantity shows as a shaded gray area in proportion to the reservoir quantity. The white digits below the reservoir show the quantity in U.S. gallons and in tenths of gallons. When the engines are on and have reached idle, the DEU sends an instruction to the hydraulic synoptic. A cyan line in each reservoir shows an initial flight quantity of hydraulic fluid. When the reservoir has less than 2 1/2 gallons, the digits are amber and show in an amber box. Reservoir temperature shows as white digits to the right of each reservoir. If the temperature is more than 100 degrees Celsius, the digits become amber and show in an amber box. In this lesson segment, we first talked about the hydraulic system in general. Then we talked about the controls related to the hydraulic system. And last, we talked about the displays and indicators related to the hydraulic synoptic page. In the first segment of this lesson, you learned how to read the synoptic page indications. Now you will use what you learned to monitor the synoptic page and the HSCP for correct system operation when you pressurize and depressurize the hydraulic systems. Because the hydraulic system can operate in the automatic or the manual mode, it is important that you know how to pressurize the system in the two modes. In the automatic mode, you will pressurize the system with the MCDU. After you pressurize the system, You will depressurize the 3 hydraulic systems and will put the aircraft back to the usual configuration. This segment will show aircraft tests and procedures to make sure that the hydraulic system components operate correctly. Because the engines will be off, you will pressurize the system with the auxiliary pumps and the RMPs. You will use the CFDS on any MCDU to control the auxiliary pumps and the RMPs. To pressurize the hydraulic systems, you must make sure that the HSCP is in the automatic mode. First, look at the HSCP to see which mode it is in. The manual light on the system switch light is an indication that the HSC is in the manual mode of operation. To set the HSC to the automatic mode, push the system switch light on the HSCP. The HSCP is in the automatic mode now. The fault lights stay on because the engines are off, but the pumps are on. The lights will stay on during this lesson and each time you do this procedure. You can use each MCDU to pressurize the hydraulic systems. For this lesson, you will use MCDU 3. First, go to the CFDS initial menu. Push the CFDS line select key, or LSK. Now go to the CFDS LRU maintenance menu from the CFDS initial menu. Now go to the HSC selection on the CFDS LRU maintenance menu. Go to the HSC selection on the CFDS LRU maintenance menu. Go to the HSC selection on the CFDS LRU maintenance menu. Push the HSC LSK to go to the HSC maintenance menu. The selection symbol shows adjacent to the Return to Service selection. We are in the automatic mode. Push the Return to Service LSK to go to the Auxiliary Pump menu. When you push the Return to Service LSK, the HSC automatically shows the results of a power-up bite test. Push the Continue LSK to continue the test. The HSC Return to Service System LRU screen has 5 pages. In the scratch pad area, the wait message shows for 5 seconds on each of the Return to Service screens. During this time, the LSKs will not operate. If you push a key, the 5-second delay will start again. This delay prevents accidental operation of the hydraulic system. On the aircraft, the return, sensor readout, and page keys will continue to operate during the 5 seconds. After the 5-second delay, the wait indicator goes off and the LSK access prompts come into view. Now push the page key to go to the hydraulic auxiliary pump selection. Push the page key to go to the hydraulic auxiliary pump selection. Push the page key to go to the hydraulic auxiliary pump selection. Push the page key to go to the hydraulic auxiliary pump selection. Before you make an auxiliary pump selection, talk with the ground person to make sure that the aircraft control surfaces are clear. Auxiliary pump 1 or 2 will pressurize system 3. Push the LSK for Auxiliary Pump 1 now. The MCDU screen now shows that Auxiliary Pump 1 is on. Before you push the LSK for Auxiliary Pump 2, look at the hydraulic synoptic page to make sure that System 3 shows the correct system pressure. The auxiliary pump indication is a green circle with green veins. When the system pressure is more than 2400 psi, the pressure line changes from white to green. Compare the System 3 pressure with the pressure specified in your student handbook. Touch the OK button if System 3 pressure is correct. Now push the LSK for Auxiliary Pump 2. The MCDU now shows that the two auxiliary pumps are on. Look at the hydraulic synoptic page to make sure that the indications are correct. Again, the auxiliary pump will be a green circle with green veins. The pressure line is green because system pressure has been satisfactory for more than 2 seconds. Look at the HSCP to make sure that the auxiliary pump lights are on and that the System 3 pressure light is off. These indications also show that System 3 has correct pressure. Now you will pressurize System 1. First, you must go to the 1-3 RMP LSK. Push the page key until you see the RMP selection. Remember that when you use the page key on the aircraft, you will not have to stop for the full 5 seconds. Push the page key until you see the RMP selection. Push the page key until you see the RMP selection. Push the page key until you see the RMP selection. The RMP selection are on page 4. The RMP LSKs control the shutoff valves and let the pump operate. Push the 1-3 reversible motor pump LSK to set the pump to on. The MCDU shows that the 1-3 RMP is on. The hydraulic synoptic page shows that the 1-3 RMP valves are open to permit System 1 pressurization. Make sure that System 1 pressure agrees with the specifications in your student handbook. The 1-3 RMP on light is on, and the System 1 pressure light is off. These indications show that System 1 has hydraulic pressure. Now you will pressurize System 2. Push the 2-3 RMP LSK on the MCDU and monitor the hydraulic synoptic page. The MCDU shows that the 2-3 RMP is on. The hydraulic synoptic page shows that the 2-3 valve is open to permit pressurization. Make sure that System 2 pressure agrees with the specifications in your handbook. The 2-3 RMP on light is on, and the System 2 pressure light is off. Now all 3 hydraulic systems have correct pressure for maintenance operations and tests. Now you will do the second part of this lesson segment. Depressurize the hydraulic systems to put the aircraft back to its original configuration. First, depressurize System 1. Push the 1-3 RMP LSK and look at the hydraulics synoptic page. the 1-3 RMP valves close, and System 1 has no pressure. The synoptic shows the valves in the closed position. The 1-3 RMP switch light is off, and the pressure light for System 1 is now on. Now depressurize System 2. Push the 2-3 RMP LSK and look at the hydraulic synoptic page. The MCDU and the synoptic page show that the 2-3 RMP is off and that System 2 has no pressure. Now the 2-3 RMP on light is off and the System 2 pressure light is on. These indications show that you have depressurized System 2. Now you will depressurize System 3. To depressurize System 3, you must turn off the auxiliary pumps. The auxiliary pump selections are on page 5. Push the auxiliary pump 1 LSK and monitor the hydraulic synoptic page. On the synoptic page, the vanes are off for auxiliary pump 1. System 3 pressure continues to agree with specifications. The other auxiliary pump continues to pressurize System 3. Push the LSK for the other auxiliary pump and monitor the hydraulics synoptic page. All indications here show that you have depressurized System 3 to agree with the specifications. Now look at the HSCP. The indications on the HSCP agree with the indications on the synoptic page and on the MCDU. Now all three hydraulic systems are back to their initial configuration with no hydraulic power. Go out of HSC maintenance and return to the MCDU main menu. When you leave the HSC Return to Service menu, the system automatically reconfigures itself for normal operation. When you leave the HSC Return to Service menu, the system automatically reconfigures itself for normal operation. Return to the MCDU main menu. Return to the MCDU main menu. The aircraft is back to the normal maintenance configuration. The MCDU shows the main menu so that other technicians can use the CFDS or the other MCDU selections. In this segment, you used the HSCP and the MCDU to operate the hydraulic system in the automatic mode. You then pressurized the three systems through the HSC Return to Service test. You monitored the MCDU, the hydraulic synoptic page, and the HSCP to make sure that the system operated correctly. Then you depressurized the three systems and put the aircraft back to the normal configuration. In this segment of the lesson, you will learn the procedures to pressurize and depressurize the 3 hydraulic systems in the manual mode. Now that you have pressurized the hydraulic systems in the automatic mode, you will pressurize the 3 systems in the manual mode. In the automatic procedures, you used the MCDU. In the manual mode, you will use the HSCP to pressurize the 3 systems. After you pressurize the 3 hydraulic systems, you will depressurize them and put the aircraft back to the normal configuration. Before you pressurize the hydraulic system, you must first make sure that the HSC is in the manual mode. The manual light shows that the system is in the manual mode. The 6 fault lights stay on during all of the procedures. The RMPs also come on when you set the HSC to the manual mode. You must turn off the RMPs before you continue. Push the 1-3 RMP switch light. Now stop the 2-3 RMP. Now you have set the HSC for the maintenance check. To start the maintenance check, you must turn on auxiliary pump 1. The auxiliary pump 1 on light comes on. The system 3 pressure light will go off when system 3 pressure increases to more than 2400 psi. The synoptic page shows that auxiliary pump 1 is on and that system 3 has the correct pressure. Now turn on auxiliary pump 2. The auxiliary pump 2 on light comes on. The synoptic page shows that auxiliary pumps 1 and 2 are on and that system 3 has the correct pressure. Now push the 1-3 RMP switch light to pressurize system 1. The on light and the disagree light come on. The disagree light shows that the valves have not moved to the correct position. When the valves are in the set position, the disagree light goes off. The 1-3 RMP is now on. When the system pressure is sufficient, the system 1 pressure light also goes off. The synoptic page shows that system 1 pressure is correct. Now pressurize system 2. Push the 2-3 RMP switch light. Again, the disagree and on lights come on. When the valves are in the on position, the disagree light goes off. When system 2 pressure is sufficient, the system 2 pressure light goes off. The synoptic page shows that all 3 hydraulic systems have the correct pressure for maintenance operations and tests. Now you will make sure that auxiliary pump 2 can independently pressurize all of the hydraulic systems. Set auxiliary pump 1 to off. The auxiliary pump 1 light goes off, and auxiliary pump 2 pressurizes system 3. Hydraulic power from system 3 pressurizes systems 1 and 2. The synoptic page shows that system 3 continues to have the correct pressure, with only auxiliary pump 2 on. Now depressurize the hydraulic system. To depressurize system 1, turn off the 1-3 RMP, and then look at the hydraulic synoptic page. The on light goes off and the disagree light comes on until the valves move to the set position. The pressure light for System 1 comes on. The synoptic page shows that the 1-3 RMP valves are in the closed position and that System 1 pressure is low. Now depressurize System 2. Push the 2-3 RMP switch light. The on light goes off and the disagree light comes on until the valves move to the set position. The pressure light for System 2 comes on. The synoptic page shows that System 3 is at the correct pressure with only auxiliary pump 2 on. Now depressurize System 3. Turn auxiliary pump 2 off. The auxiliary pump 2 light goes off and the System 3 pressure light comes on. The synoptic page shows that auxiliary pump 2 is off and that pressure is low. You will now put the aircraft back to the normal configuration. Set the HSC back to the automatic mode. Good. The HSC is now back to automatic mode. The aircraft now has no hydraulic power. In this segment of the lesson, you learned the procedures to pressurize and depressurize the 3 hydraulic systems in the manual mode. In the manual mode, you used the HSCP to pressurize the systems. Then you depressurized the 3 systems and put the aircraft back to the normal configuration.